I recently found this rather interesting Bluetooth board online. For a price of roughly $5, it combines a Bluetooth IC with a PAM 8403 2x3 watt audio amp IC. By connecting an old speaker to one of its outputs and powering the board through a 5V phone charger, it comes to life and is apparently Chinese.
The Bluetooth device is ready to pair.
After pairing my phone with it, I was able to play back my favorite music just like any other Bluetooth speaker would do so. But even though the setup is functional, it is also rather crude and impractical. So in this video I will show you how I use this board in combination with some other easily available components to create my own low budget portable Bluetooth speaker. Let's get started. As a power source, I went with two 18650 lithium-ion batteries with a capacity of 2800 mAh each. You can get comparable ones for around $10. To charge them and protect them from over discharge, I went with a TP4056 board whose B+ pin connects to the positive terminal of the batteries and the B- pin to the negative terminal. You can find such a board for around $1.4. To position the charging port more accessible later on, I also added a micro USB breakout to the mix, which directly connects to the input of the TP4056 and only costs $1.2. At the positive output pin of the protection board connects a single pole double throw switch for $2, followed by a MT3608 boost converter for $1.2. whose negative input connects directly to the negative output of the TP4056 board. After adjusting the output of the boost converter to 5V through the built-on trimmer, all that was left to do was to connect the outputs to the 5V and ground pins of the Bluetooth board. By flipping the power switch, the board blinks like it's supposed to, but we will need some decent speakers. For that, I luckily had two old speakers from a Logitech speaker system laying around. I simply removed all the screws that held the case together and removed the bare speakers. After connecting them to both channels of the Bluetooth board, it seemed like everything still worked fine, but I was not pleased with the signal LEDs for the charging process. So I removed both of them and asserted that they have a common anode, aka a common positive terminal. That is why I replaced them with a common anode RGB LED, whose blue pin I cut and then connected each wire to its solder pad respectively. All in all, this setup came out to a total price of $22 without speakers. Pretty decent, I would say, considering that the battery runtime is at least around 30 hours at an average loudness. Now that I knew that this setup works, all that was missing was a case. For that, I firstly measured the dimensions of all the components and subsequently drew a rough sketch with vague measurements. Next, I added a square wave pattern on each side, which will later interlock with one another to form a sturdy case. According to those sketches, I drew a proper blueprint with the Lookalike software, exported each piece as a PDF file and printed out each file twice. Afterwards, I used a cutter to follow the outline of the 6 necessary pieces and then used an X-Acto knife to cut out the inner parts of the square wave pattern. After completing the templates for all the pieces, I got myself beech plywood, 6mm thick to be specific. I simply used a glue stick to apply a generous amount of glue to each template and then pressed it onto the plywood. With the help of a simple handsaw, I cut roughly along the outlines of each piece and then completed the outline through the help of the scroll saw, right before I used the saw as well to cut out the inner parts of the square wave. And just like that, all the pieces for the case were complete, but their locking pattern didn't fit well yet. So I used a file to solve this problem and continued by marking the center points on the right and left side of the case in order to mark a circle with a diameter of 72mm for the speakers. Afterwards, I drilled a 6mm hole in the middle so that a saw blade could be inserted and sawed the cutout for both of the speakers. Next I marked the mounting holes for the Bluetooth board onto the top section of the case and created them with a 3mm drill. The next marking was in the middle of the front board, which I used to drill a 6mm hole for the switch, followed by a 5mm hole 20mm underneath the middle hole. At last I positioned the micro USB breakout in the middle of the latch of the bottom case piece, marked the 3mm mounting holes, created them, mounted the PCB temporarily to the wood in order to mark the necessary cutout on the front piece of the case, and cut it out afterwards with the scroll saw. Next I scraped off most of the paper template through brute force, but eventually used a tactic consisting of applying acetone and using a spatula-like object, in this case my ruler, to remove the paper completely. Now that we finally have 6 beautifully crafted case pieces, it was time to secure the speakers in place with M4 bolts and nuts, the micro USB breakout with M3 bolts and nuts, and the M3 mounting bolts for the Bluetooth module. Afterwards, I applied a decent amount of wood glue on all of the case sides in order to connect them together. But needless to say, the back piece should not be glued in place, otherwise we could not access the insides. Once the glue was dry, I repeated the same wiring as I described it at the beginning of the video. Only difference was that I added a bit of hot glue to a couple of parts to secure them to the wood. Otherwise it was completely the same procedure. But if you're still confused, you can find better pictures, a parts list and everything important as always in the video description. At the end I pushed the back piece in place, which should fit snugly, and the project was finally complete. I have to say that I'm pleased with how it came out, and the sound quality and volume is pretty decent. I hope you liked this video, and maybe give this project a try. Don't forget to like, share and subscribe, that would be awesome. Stay creative, and I will see you next time.